Welcome to Mathematics and Home. In today's class, we're dealing with this problem. And we have to find the value of x here, meaning 2 raised to the power of sine square x plus 2 raised to the power of cos square x equals to 3. So we are asked to find the value of x. So now let's see, how do we find the value of x? Here we see we're going to recall from our first identity equation. Identity equation 1 says sine square x plus cos square x is equal to 1, right? From first identity equation. So now if I make cos square x the subject, I will have cos square x is equal to 1 minus sine square x. So instead of writing cos square x, I can substitute the value of 1 minus sine square x in place of cos square x. So now in substitution, we say therefore 2 raised to the power of sine square x plus 2 raised to the power, instead of cos square x, I will substitute it by this 1 minus sine square x, so that everything will be in form of sine. I can substitute also for sine square x to be 1 minus cos square x. It's still the same thing. So this is equal to the value 3. So now we're going to relate this function now by the knowledge we acquired in indices, right? So now this function can be written as 2 raised to the power of sine square x plus 2 raised to the power of 1. This is equal to 2 raised to the power of 1 times 2 raised to the power of minus sine square x equal to this 3. So now I split this into 2 using the knowledge of indices. So again, this can still be written as 2 raised to the power of sine square x plus 2 raised to the power of 1 times 1 over 2 raised to the power of sine square x. Meaning this negative sign has turned into the reciprocal of this function. If I remove the negative sign, I will have the reciprocal, meaning 1 over this function, 2 raised to the power of sine square x. So it's equal to this 3. So I can multiply this times 1, 2 raised to the power of 1 times 2, right? So this is to see the value now, 2 raised to the power of sine square x plus 2 raised to the power of 1 divided by 2 raised to the power of sine square x is equal to 2. So from here I can start by assumption. Let me say, let the value 1 equal to 2 raised to the power of sine square x, meaning the whole of this 2 raised to the power of sine square x will be equal to 1. So wherever I see 2 raised to the power of sine square x, I can substitute it by y. So now replacing this value by y, I will have y plus 2 raised to the power of 1 is 2 divided by 2 raised to the power of sine square x is also 1 is equal to this 3. So from here I can find the LCM between these two fractions. If you don't want to find the LCM, you can go back to our previous video. We did a video on how to simplify this fraction. So to simplify the fraction, we multiply these two integers together, y times 1 will give us y squared plus 2 times 1 will give us 2 divided by 2 times y, 1 times y will give us 1. So this is how to multiply the fraction, or to simplify the fraction easily without finding the LCM. So it's equal to this value 3. So next, I can cross multiply from here also. Multiply this y by 3. So I'll have y squared plus 2 is equal to 3y. Take these 3y to process the equality. I have y squared minus 3y plus 2 is equal to 0. This is now a quadratic equation. So I can solve this quadratic equation either by completing the square method, by factorization, or by formula. Whichever method is suitable for us, we can use it and solve the quadratic equation. But today I'll be using factorization, which is much more easier. So now to factorize this, here we'll be looking at 2 factors such that when you multiply this and this, you have 2y squared. Then the middle value is minus 3y. So now we look for 2 factors such that when we multiply the 2 factors, we are going to have this. And when we add the 2 factors, we are going to have this. So if I have 2 times 1 is 2, then 2 plus 1 is 3. But this is minus 3. So if I put minus 2 times minus 1, minus times minus is plus, 2 times 1 is 2. Then minus 2 Plus times minus is minus. So minus 2 minus 1 is minus 3. So I'm going to have two negative values, meaning minus 2y and minus y. Minus 2y minus y will give us minus 3y. Minus 2y times minus y will give us plus 2y squared. So now this time my value is minus 2y and 1. So now instead of writing the middle number here, I can substitute it like this because it's still the same. So now in substitution, I have y squared minus 2y minus y plus this 2 is equal to 0. So find the value of y, or factorize here. What is common between these two is y. Factor out y, we will be left with y here, minus factor out y, we will be left with 2 here. What is common between these two is minus 1. Minus 1 is common, right? If you remove minus 1 here, what will be left is y. Remove minus 1 from this plus 2, will be left with minus 2. Minus times minus will give us plus is equal to 0. So if you look at these two brackets, they are equal. So it's going to be either y minus 2 or y minus this one. Y minus this one will not be equal to 0. So if y minus 2 is 0, if y minus 2 is 0, then the value of y is equal to 2. In the first case, y is equal to 2 if y is 0. So again, we say again, if the second bracket is equal to 0, the second bracket y minus 1 is equal to 0, then the value of y is equal to 1. So it's either y is equal to 1 or y is equal to 2. But remember we said y is equal to sine square 2x. Y is equal to 2 raised to the power of sine square x. So substitute for y. When y is 2, 2 is equal to 2 raised to the power of sine square x. Again, from the knowledge of indices, we know that any number has a power 1. This 2 has a power 1. 2 raised to the power of 1 is still 2. So mathematically, it didn't change anything. So 2 raised to the power of 1 is the same thing as 2 raised to the power of sine square x. And by law of indices, it says when the bases are equal, if the bases are equal, then the powers must be equal. So we are going to equate the powers now. Therefore, we said sine square x must now be equal to 1 since the bases are equal. So if sine square x is equal to 1, what is the value of x? We are going to multiply 2 by 1 over 2 or take square root of both sides. So when we take square root of both sides, the power here is going to vanish. So I have sine x is now equal to square root of 1, and square root of 1 is 1. Therefore, sine x is equal to 1. So what is the value of x? X is equal to sine inverse of 1. And what is sine inverse of 1? Is 90. Sine inverse of 1 is equal to 90 degrees. The next, is to simplify or substitute for y equals to 1. When y is equal to 1, then what is going to be the value of x? So again, when y is 1, when y is equal to 1, this implies that 1 is equal to 2 raised to the power of sine square x. We know that y is equal to 2 raised to the power of sine square x. So we're substituting the value of y to be 1. If 1 is equal to this, then there is a way I can write this 1 mathematically. When I say 2 raised to the power of 0, it's still the same thing as 1. So I have 2 raised to the power of sine square x. So this I didn't change anything. 2 raised to the power of 0 is 1. So anything raised to the power of 0 is 1. So now, if these bases are equal, then the powers will also be equal by the law of indices. So therefore, we say sine square x is now equal to 0. Therefore, when we take square root of both sides, sine x is going to be square root of 0. Square root of 0 is also 0. Therefore, x is equal to sine inverse of 0. And what is sine inverse of 0? Is 0. Sine inverse of 0 is 0. So now the value of x is either 90 or 0. How do we prove that? If x is 90 or if x is 0, to prove that, we know from the equation they say 2 raised to the power of sine square x plus 2 raised to the power of cos square x is equal to 3. This was the equation given. So I want to prove the answer. I want to prove that this is equal to 3. when we substitute the value of x to be 0 and x to be 90. Take for instance the first value of x to be 90. When x is 90, substitute for x to be 90 here. We have 2 raised to the power of sine square 90 plus 2 raised to the power of cos square 90 must be equal to 3. If this value is not equal to 3, then the result is not correct. So now what is cos 9 sine 90? We have 2 raised to the power of sine 90. We know that sine inverse of 1 is 90. Then therefore sine 90 will now give us 1 if we take it the other way around. So therefore I have 2 raised to the power of sine 90 is 1 and 1 square is also 1. So I have 1 plus 2 raised to the power of cos 90 is 0 and 0 square is also 0. So I have 0 is equal to 3. 2 raised to the power of 1 is 2. 2 raised to the power of 0 is 1 is equal to 3. So 2 plus 1 is 3. 3 is equal to 3. So therefore the value for 9 is 90 is correct because the value the right hand side is equal to the left hand side. Again, to prove for x to be 0, when x is 0, let us also prove the equation. When x is 0, put x to be 0 here. I have 2 raised to the power of sine square 0 plus 2 raised to the power of cos square 0 is equal to 3. So it must be equal to 3. So now sine 0 is 0. 0 square is also 0. So we have 2 raised to the power of 0 plus cos 0 is 1. Cos 0 is 1. And 1 square is also 1, so I have 2 raised to the power of 1. In the press of we have these values. The 0 and 90, 0, 90, 30, 45, 60, they are all special numbers. We all know how to derive that. So now cos 0 is 1. When cos 0 is 1, 1 square is also 1, so we have 2 raised to the power of 1, and it must be equal to 3. 2 raised to the power of 0 is 1, plus 2 raised to the power of 1 is 2, is equal to 3. So 1 plus 2 is 3, 3 is equal to 3. So therefore the right hand side is equal to the left hand side. And that is it. We have successfully proved this equation is equal to 3 by substituting the value of x that we got, which is 0 and 90. And that is it for today. Thank you for visiting our channel. If you have any question, you can drop it in the comment section. And if you are visiting the channel for the first time, kindly like, subscribe, and hit on the notification bell. See you some other time. Thank you.